Okay.
Yes.
So you can see. Okay. Okay. So you can see the whole page, I think.
Yes.
Okay.
This is the page and the keyboard and
All right.
and a lot of more. Yeah, but good. I think it's
All right.
good.
All right. So let's start.
If you want, you can pin the video if you want. Karthik, Sriraj, and do you know how to pin the video? That's might make it bigger. I think right click and yeah, you guys know. Yeah, now it's very readable. Yeah.
Okay, very good. Okay, so let me tell you the final goal. The final goal is to build an electrical circuit for RC car. RC. Anyone knows what's RC stands for?
Remote control.
Remote control. Yes. Remote control car. In the remote car control, you pretty much do a lot of things. You decide whether the car will go forward, backward, and then it will go. You can also make the orientation to go left and right. So there are multifunction. So this type of control or remote control circuit will make or does or do a lot of things. I'm not sure if we are gonna build such complete RC circuit or RC car. So the target is to build a car that moves in one direction, and then with the remote control we can stop the motion. That's at least we should get that goal. We might do better, depends on how things are going. We can make the full functionality RC car, but worst case, we'll get a car that can be controlled remotely to move forward or stop. But we are gonna take the longest approach to this. We are gonna talk about electricity in general. So we're gonna talk about electricity, and then we'll talk about electrical circuit. We are gonna talk about also electronics. And then we will talk about like building useful circuits towards the end. So we are gonna talk about electricity from the basic definition and basic meaning of the word, and how the civilization embraced this force to create the modern life we have today. Today we are you guys are in a different continent, but we can still have this lecture thanks to the power of electricity, something our ancestors would not have dreamed of achieving. So some of you might have already studied this, the definition or what is the exactly what electricity is exactly. Nevertheless, we're gonna talk about it today. But before we talk about that, let us try to see the power of electricity and how this shaped our life nowadays. let us start with, in fact, for example, the telephone is a very important application. And in a telephone, you can talk to someone that is far away because of electricity. So anyone knows who invented the telephone? So that's the question. Who invented the telephone?
I think it is not audible. You want to be louder a bit.
Okay. So
No,
anyone knows?
not us, not Sami. I think the students are answering. I think we cannot hear.
Okay.
So we are not sure about the answer.
Okay. Yes,
Okay.
we are not.
So I think Graham Bell is the one accredited for the invention of the telephone. Of course, these inventions usually are not the effort of one person. It is the effort of so many people with so many ideas. But Graham Bell was the first one that was able to send a voice over electricity to another room, and the first words that were ever transmitted using electricity from one room to the other is what Graham Bell spoke on the phone to his assistant when he tested this. And actually, I forgot what is the first word Graham Bell spoke. I'm going to search Google. So what is the first word Graham Bell
So I have a question.
Spoke.
I have a question.
Yes.
So Morse code, was that before telephone, or that's considered telephone too? The just did that dots.
I think the Morse code and the telegraph was before the telephone, but
So
the
we're
telegraph.
talking about sound.
Yes, exactly. The phone. Yes. So telegraph was before, and the Morse code was a genius way to code messages efficiently. More frequent letters has short code words, and less frequent letters has a longer code words. Oh yeah, so I found that. Okay, so here is what was the first word ever spoken on the telephone. They were spoken by Alexander Graham Bell, inventor of the telephone, when he made the first call on March 10, 1876 to his assistant. It was Mr. Watson. The name of his assistant was, "Come here, I want to see you." So that's was a very important invention and application of electricity. So I'm going to move also next to, of course, this telephone was a wired telephone. You need a wire from that connect the two people together. But Marconi, he invented basically the wireless telephone or the wireless telegraph. And so his name is Marconi. I'm not sure if I have pronounced the words correctly. I think Marconi, I think Shajesh won Nobel Prize, right?
I don't think so.
Oh, okay. Okay. So he is the. Oh, actually, he does.
It does.
Yeah, I checked. Thanks to Google, I think he actually, when I read about him that he won Nobel Prize, I was really surprised.
Okay. Okay.
Probably the first Nobel Prizes in 1909.
Okay. Okay.
So Marconi actually accredited of saving the lives or many lives over the Titanic. So when the Titanic hit an iceberg, it started to sink. The people on board, they send a wireless telegraph message about the accident, and in few hours or maybe half a day, they send the rescue team. And because of that, many people survived the accident. And Marconi personally actually accredited for saving their life with this invention. And wireless is actually one of the greatest invention and using of the power of electricity, or the power of electricity to transmit messages wirelessly. We can talk from like the phone, wireless phone, computer when they communicate with each other. When we talk with the space station, it's the power of the wireless technology is beyond beneficial for us, and it's all based on electricity. The second or the next thing that comes from the power of electricity is the radar. And of course, radar, I think it historically invented after the World War II or at the end of World War II. And so radar is used basically to detect target in space, like, for example, an airplane. Now, busy airport, like the Indira Gandhi airport is among the busiest airport in India. I don't know how many airplane land every day. It's all possible because of a radar, where the radar basically transmit electromagnetic wave, and that reflects from the airplanes, and there's a receiver that receives that wave, the reflected wave, and decide the location of the airplane. A very important application of the radar, which is not as common, or it's important application in weather. A lot like tornadoes, hurricanes, it can be detected thanks to the radar. That basically enable us to have a warning whenever we have a tornado coming. We can detect it on the radar. Actually, I don't know if you guys know this. I learned this by my friend told me about it. Actually the tornado is not detectable by the radar wave. However, the tornado surrounding has a lot of moisture and also a lot of insects, and these reflect the wave, and that's it become clear on the radar screen. So this is the next application.
Tell that again, the last part. Can you repeat?
So the vortex of the tornado, the radar cannot detect it. It's not detectable by the radar. However, around the tornado, there is a group of insects and moisture that reflect the radar wave, and then we see it on the radar screen.
I see.
The second application, but by the way, these are not historical. The the light bulb. Okay, I think I wrote that right. So anyone knows who invented the electric light bulb?
Thomas Alva Edison.
Yes, Thomas Edison. Very good.
Like, did he really invent it, or there was a electric bulb there even before him?
Yeah, I'm not sure. I know that he came up with the filament that used to make the inside of the bulb, and he tried like 1,000 different filament types, and he found the one that actually worked.
It was
But
possible to make it commercial, I suppose, that it lasted for sufficient number of hours that it became economical to sell
yes.
an electric bulb.
Yes, actually, his invention also included a patent where the light bulb is screwed to the base with two small pins on the side. And that's like a very important patent for Edison, because he could market this and nobody else could manufacture a bulb with these pins. So when the competitor, I think his name is Tesla.
Okay, Nicholas Tesla.
He wanted to use this bulb for the World Fair in Chicago back in the day. And Edison said, no, you cannot use my idea for a bulb. Then Tesla did not stop there. He invented the bulb where it has a screw to of course it is more expensive to manufacture than this one, but you have to use this one if you don't want to use Edison patent. Yeah, these are the two, Edison and Tesla. They were rivals, and their rivalry brought the best invention to us. Let's move on to the next application, which is the computers. And computers is a very general word. It doesn't refer only to a device where you have a monitor and a keyboard. It is one of them, but anything that has a computer chip is considered a computer. Like, for example, the cell phone has a computer chip inside that handle all type of tasks. Especially nowadays, we have smartphones where the phone can do is a camera, is a phone, it's a voice recorder, a video player. You can browse the internet, so it has multi-functionality inside it. Our cars has three important type of computers. The computer that run the engine. The engine has a computer. So we have engine, computer. Also, the transmission of the car has another computer to make it work. So we have transmission.
So does every car engine need a computer to work, or is it only the modern cars?
Like the cars that came, basically the cars with fuel injection systems. The fuel injector engine need a computer to make it work. Yeah, the cars with carburetor, they don't need a computer specific, but the fuel injection subsystems in engine require basically a very accurate timing of the injection process and the ignition that need a computer to handle that. And because of that, the emission of toxic gases from the combustion is way less when you control that with a computer instead of using a carburetor. The third computer is the infotainment, the computer that run our radio, our apps on the car, control the AC inside the now like car. Every car nowadays has a small screen in addition to the dashboard that has information about radio, music, and so on. They call it infotainment system. These are not only this is I mentioned 3, but in fact a modern car may have more. We were talking about the other day how many computer Tesla has. It has like a lot, including, for example, the Tesla self-driving computer. Tesla self-driving a computer, or maybe more than one computer. Okay. So car has computers, our cell phone has computers, our air conditioning has computer. Pretty much every device that is like, for example, even like the thermometer, that the electronic thermometer that measure the temperature of the patient is let's talk about TVs. Like TV, it has a computer inside. So TV has a computer inside. Anyone can suggest a device that has a computer? The list is long, but anyone can help to give us like a new or examples or of devices has computers. I'm sure the refrigerator has one.
Make that clear. I think we couldn't hear.
Camera.
Yeah, very good.
Yes. Repeat that. Phone.
Clock.
Oh, clock. Alarm clock.
Oh, clock. Yes.
Yeah.
That's a good example.
Yeah, very good. Yeah. So what are the devices that do not have a computer? Bike. Yeah, bicycle, you mean. But a motorcycle has a computer, I suppose, right? So what is a carburetor?
It's a fuel injection method, right?
It is not clear. I think you're echoing.
Is it a fuel injection method?
I will have to give it to Sami. Sami, you want to?
Okay.
Sami, can you hear us?
Just yes, just give me a second. Let
Yeah.
me try. I'm gonna try one thing.
Uh-huh.
Okay. Now I should be able to hear you guys. Okay.
Actually, I was asking what are the devices that do not have a computer? And then I was asking what is a carburetor? And Joan answered it is a firing device. Right?
Is it a fuel injection method?
Yes.
Fuel injection?
I think so too. I think it is the fuel injection method, but I'll let us Sami point.
Yeah, the carburetor is the one that mix, I think, the oxygen with the fuel and send it to the engine, right?
So why can't we use carburetor when there are more than one engines, just because you want to time the whole process, is it?
Yeah, I think so.
Okay. Okay.
Okay, so so I'm gonna add a few examples. Airplane. It has like so many computers, avionics, autopilot, and rockets. The rockets that we send to the moon, we send to the Mars. Robots that does a task. The automation, the autonomous systems in different places. So the list is infinite. There is no everything in our life has a computer inside. Okay. So as you can see, the application of electricity is huge, and it is important, and it has a lot of application in our life. So let us then try to see what is exactly electricity, and how people came to know about it, and then probably by the time we are done, we will reach the end of our lecture today. But probably next time we might be able to reach a point where we can have one simple circuit with electricity. But let's talk about the electricity and from a historical point of view, or what exactly is electricity. So the first experiment that humans did to discover electricity with, basically, if you take a rod of plastic. So this is a plastic rod, and you have a cloth of wool. And you basically you rod against the wall for like few times. If you do this, and then if you bring another rod, a plastic rod, and you do the same thing, you also rub this plastic rod with the wool a few times, and then you bring them against each other. So if you, for example, with a string, you hang on the first rod, and then you also bring the second rod, and then you put them what people saw that these will repel each other. They will repel each other. And people like were really surprised back then because there is nothing visible between them that causes such motion of repelling motion. Then basically the idea of the electric charge came to exist, or people discovered the electric charge this way. Electric charge. So when the plastic rod is basically rubbed against the wall, it accumulated electric charge. And then we did for both. And the electric charge basically caused these electric charges don't like each other and they repel. And they did another experiment, but this time they did it with a glass rod, not with a plastic rod. And why this is important? Because with this experiment, there is only one type of charge needed to be discovered. Or if that's the only thing we have, then we can say we have one type of electric charge.
So how does this experiment clarify that there are two types of charges there?
Yeah, that is when people did the same experiment with a glass rod. So people got a glass rod, and then they have a piece of silk, and they rub the glass rod against the silk cloth, and then they actually got two of them. This is a glass rod, and this is a glass rod, and both of them rubbed with the cloths. And what happened? Exactly the same thing. The rod, basically, they repelled each other. And the explanation was also electric charge. And the surprise is what when they put a plastic rod one plastic and the other is a glass, and the surprise that they attracted each other. This experiment gave people the belief that not only there is one type of charge, but there are two types of charges. Such that one type of charge that comes when you have plastic rod, and these charges repel each other. And the second type of the charge type is the one that comes with the glass rod. They are also repel each other. But when you bring these two different charges together, because different charges, they attract each other, the glass rod and the plastic rod attracted each other, and they wanted to come closer to each other. This gave people the idea that there are in nature two types of charges.
Is it possible to explain this experiment with 3 types of charges?
So, yeah, so like,
Or my point is, historically, was there any suggestion that there could have been such possibilities? Like, because in the early studies, they must have been confused, right? Or it may not have
Yeah.
been convincing enough. So probably, or was there any such discussion? I really don't know the answer myself.
yeah, I don't know the answer myself either, and it's gonna be very interesting to find out why people stopped at these two types. Yeah, definitely. And I actually wonder how long they thought that there's only one type of charge till they discovered that there's another type.
Yeah.
Yeah, that's probably something we can look at. And if you have 3 type of charges, like for example, type A, type B, type C, we know that A and B attract. A and B, for example, attract. Yeah, it become more complex, I think. I don't know what's the history, but we can read about it. So this way, people discover that there are 2 types of charges. I think it's a matter, and then they name the charge on the plastic rod. They give it the name negative. Is that correct, Shajesh? If you remember.
Probably, yeah. I don't know the history so well, but
Yeah.
correct. Yeah, I mean, this is how I would think it is. Yeah.
Yeah, I'm not sure about the name, but whether, but if I remember correctly from my 10th grade, and then the one this is on the one that comes on the plastic rod. And then the one on the glass rod, it's given the name positive. This is negative electric charge, and that's the positive electric charge, and it is given this name. Okay, so and so apparently these charges, similar charges attract or repel.
Question, I think.
So so we have positive charge and positive charge. They are gonna repel each other, or they are going to attract each other. Which answer is correct? Answer A or B?
A.
Very good. That's the right answer. Same thing for the negative charge. Since because these are same, they repel each other. But when you have a negative charge and a positive charge, 2 different charges, they attract. And that is that's the basically the electric force in nature. Now, so this is one of the fundamental forces we have in nature. Can anybody think of another fundamental force in nature we have?
Nuclear force.
Didn't hear you. Can you repeat again?
Gravitational force.
Yes.
Magnetic force.
Yeah.
Nuclear.
Yes. Actually, yeah, we had magnetic force. And yes, and these together, because they are very similar and they come from the same sources, they combine into one bigger force called electromagnetic force. And somebody said the gravity, right?
Yes.
Yes. Yeah. Gravity. Now, let us have an exercise. What is how gravity is different from the electric force? So how gravity and electromagnetic forces are different. So I'm gonna give the first difference, and then you guys will help me with the rest. So one difference is gravity come from mass, but electromagnetic force come from electric charges. That is one difference. Now let's see who can give me the second difference.
Gravity attracts everything.
Yes.
Charge force. Every charge. Everything.
Yeah. So so gravity only attraction. Only attraction. However, but electromagnetic force can be attraction. It can be repulsion, right?
Yes.
Okay. So let's stop here at the difference between gravity and electricity difference, and move on to the next things that we would like to talk about. We can talk about also how people discovered magnets, but we don't want to spend too much time into the history. So right now we are let's see how we can make charges move, because when charges moves things become more interesting and more exciting. So just it's almost time. Can we continue for 10 minutes or
Sure.
we
Yeah.
have to stop at
No, there is no such strict thing. I mean,
Okay.
students, if they are available, like,
okay. So since we started late, we'll continue a little bit and then we'll stop soon.
Very reasonable. Yeah.
Okay. So so the idea is let us so people discovered that we have electric charges and then they discovered there are positive charge and negative charge. And people did not know back then what exactly these charges, who carries them. Later on, they discovered that that atoms, which basically makes up everything we see, like for example, among the most abundant atoms in our bodies, actually the carbon, I think, or oxygen. Let's talk about the most important atom in our bodies, the carbon. If we look into the carbon, it has the nucleus, and that has 6 protons. So protons. So 6 protons that makes the nucleus, and then away from the nucleus we have 6 electrons. And people discovered that the negative charge actually is the charge on the electron. So each electron has a negative charge. And the proton, on the other hand, has a positive charge. So the proton is positive charge. So if we look into the classical picture of the atom, of the carbon atom.
Oh, did we just lose Sami?
Yeah, he got disconnected.
Yeah. Okay, so we'll give it a minute. I think probably something happened. Yeah. Is this all familiar topics?
Yes. Yes.
Okay, good. So, good. We also have April Handley here in the audience, and she's also in physics, and her she has done astrophysics as a specialization. April?
Hi.
Hi.
Yeah. Would it be correct your specialization is astrophysics, or is it astronomy?
I say either one sometimes because
So many of the students here who are in this today present here, they all have an interest in astrophysics.
okay.
So that's nice that you log in on the day when they are here. Yeah.
Yeah. Well, I just got home right when I logged in, so
I see. Yeah, good. They were wondering if they can hear something about redshift.
well, like whenever something's moving away from us, well, like if you're listening to something pass by, like a car or train or something, as it passes by, the pitch changes. Like
Yes.
Anyway, light does kind of the same thing, except for what happens is it basically, like if it's moving away, the wavelength gets longer and gets towards the red part. And basically call that redshift. Like, and in the universe, basically the universe expanding, and that means because of the expansion of the universe, things are moving away from us, and basically that causes all the light to get shifted to longer wavelengths. And so if it starts out like green, it might get shifted more towards red. If it's red, it gets shifted towards ultraviolet, or not ultraviolet, infrared, sorry, and so on. So
Okay.
I don't know how. So
While we wait for Sami, you guys have questions, general questions for Astro? Someone in astrophysics?
I know. Yeah.
Was April's response clearly understood? Like, could you understand? Okay. Good. There is a solar eclipse coming in the end of April. It won't be, I don't think it is there going through India, correct?
I was gonna say, if you're talking about the one, I think you're talking about the one that goes through Australia.
Yeah.
I think it's going to miss India.
Okay.
So I'd have to take.
Hey guys, sorry, I lost.
Yeah, we noticed.
Yeah. So okay, so we should be able to continue the last few minutes.
Mhm.
Okay. All right.
We'll change the camera direction.
Yep. Okay. Okay. So we're talking about the carbon atom, and then we said that the carbon has 6 protons. Each one is positively charged, and it has 6 electrons. So this is a classical model, which is wrong, but it explains some properties of the matter that we say that the electrons rotate around the nucleus, the electrons, in an orbit similar to the solar system. However, this model is completely wrong, but nevertheless, I'm going to use it to talk about the electricity. For a while, this was the model for the matter and the atoms, and it was able to explain so many things till it stopped able to explain new things. But in general, so people discovered that the electric charge that we saw on the plastic rod is actually nothing but electrons moved to the glass rod. And the positive charge on the glass rod are coming from the atoms that are lost electrons, and they become positively charged. And these charges, as people discovered, are coming from the atoms, and the atoms that contain electrons and the protons. So all the atoms have same number of electrons as protons, and that's important because the total charge of the neutral atoms are 0. And this is actually the reason why there is life, and our bodies or everything around us have atoms, and these atoms are balanced or in neutral, or they have the positive charge and the negative charge. They balance and they cancel each other. That's otherwise, if our atoms are charged, we will be attracted to other objects, and other objects will repel us and motion will become impossible. But atoms are in neutral. However, we can easily separate, like when this atom loses an electron. Then, if this atom loses an electron, then it will become, it has 5 electrons negative and 6 protons that are positive, and together will have a carbon atom that is positively charged. At the same time, another carbon atom that has 6 protons, it might get a new electron, then it will have 7 electrons, and then it will become negatively charged. And that's how we can have some positively charged object and negatively charged object. So I'm going to talk about the last thing before we stop, which is basically the motion of the charges in free space. So motion of charges in free space. If
What
we
does
have
free space stand for?
means like outside electric wires, just
Yes.
in air, if you per se, not inside wires. So we can understand the electric field, and then we'll move next time for the electric circuits where we have electric field inside wires. So if we have, for example, a positive charge, and I'm going to fix this charge. I'm not going to let it move. And then I have one electric charge that is positive. If I allow this charge to move, what will happen that this charge is going to move away because of the repulsion force from the this positive charge. This is due to a force, which is, we call it the electric force. Now, one of the advantages of our civilization is we can calculate things, not only talk about things, but we give them a precise numbers. The quantity of charge is given a unit called coulomb. And usually it is, we can give it a symbol. Let's assume that the charge here has a quantity called a Q1, and this charge is a Q2. This is equivalent, similar or analogous to the mass has unit of kilogram. Same thing, charges has units, we call it coulomb. We are not going to use this equation a lot, but I'm going to write it down and talk a little bit about it. There is an electric force between these two charges that depend on the distance. If this distance is, for example, d, the force between these two charges is F, and that is equal to a big number, which is 9 10 to the power 9, times the quantity of the first charge, multiplying the quantity of the second charge, divided by the square of the distance between them. And that's called Coulomb's law. So I'm not going to write too many equations, but I felt that this equation is a very important equation. So if we increase the amount of charges, the force will go up. But also, if we increase the distance between them, the force will go down. usually let us have a small exercise where we need to calculate the force between two protons. Let's calculate the force between two protons. So if we have one proton here, and we have one proton here, and the distance between them is 1 millimeter. What is the force between them? The charge of the proton is 1.6 10 to the power minus 19 coulomb. So that's the first charge. The second is also a proton, so it's going to have the same charge, which is I'm going to have Q1, and Q2 is 1.2 10 to the power 9. Sorry, 1.6 10 to the power minus 19 coulomb. So let me write down the equation. You don't have to write this, just for you to have a flavor of forces between two protons. So 10 to the power 9, 10 to the power 9 times the charge Q1, which is 1.6 10 to the power 19. And then the second is 10 to the power 19 also, divided by 1 millimeter, which is 1 millimeter is 0.001 meter. So here I have 100.0 square. So if so, this is 10 to the power 9. So this is 1.6 times 1.6. Then I have here 10 to the power minus 28. So this is, I'm going to square the 1, but I have 3 decimal points for each number. So this is going to have 6 decimal places. So this gave me this. So I'm going to use my calculator to give you the answer quicker. Well, I'll do it in a slow motion. So 9, then 1.6, 1.6. This and this, I can add them. This will be minus minus 29. 1 second. Oh, I made a mistake. This is 83, 38, right? And now I have 29. And then this one is 1, 2, 3, 4, 5, 6. So 1, 10 to the power minus 6. So that is 9. 1 to the power 9, 10 to the power 6. And then this will be minus 29 plus 6 is going to be 23. So as you can see, this is a very small number. But let me do the 9 times 1.6 times 1.6. I will get a 23.04 10 to the power minus 23. Now, anyone can tell me what is the unit of the answer?
Newton.
Excellent, in Newton, because it is a force. So we noticed that the force is very small, right? This is a very small force, which give us an idea that if we need to have forces that are considerable, we need to have a lot of these protons. That's why in electric circuits, where we have batteries, usually to create a useful amount of force and currents, the number of the electric charges, which are electrons and protons, need to be huge. in billions and billions. Otherwise, so if you have an electric circuit where we have a battery and, for example, a light bulb, the amount of charge that are moving is not going to be 1 or 2 proton every second. It's going to be like trillions and trillions, because each one proton or electron contribute so little. So that's why we need many of them to have useful application. So let's keep going, and I think we could be done in a couple of minutes. So if we have again an electric charge here that is positive, an electric charge here that is positive, and we let this move freely, it's gonna move in this direction because of the electric force. And the scientists invented the concept of field because there is nothing between these two charges. So they did not know what exactly the reason why this charge is going away due to the electric force. They did not know what is the source of the electric force. Therefore, they assumed that the electric charge, any electric charge, they create a field around them. And that field is called the electric field. And what's happening is this electric charge, it is going to feel the electric field of this charge. And because of that, this force, this charge will feel that electric field in terms of force and start moving to the right. And that gives us the concept of the electric field. So keep in mind that we have electric field till we meet next time.
Nice, thanks. I have a question, very slightly different. When birds sit on electric wires, Sami, you can hear us?
Yes.
They don't get electrocuted?
Yes.
Why not?
So this will be in the heart of what we are going to talk about next time.
Okay, so maybe we should wait until next time. Maybe then we can all think and come back.
Yeah, I mean, I'm gonna give a hint about what we'll talk about next time by answering this question. We don't really care about the electric field. The electric field is not the final product that we need in our life. You can have all the electric field. You can even generate electric field for free. If you are smart enough, you can make electric field for free. You can have all the electric field that you want, but that is not gonna do us any good, because we need in our application the motion of the current, motion of the electric charge, motion of electric charge. That is what we are after as an application of electricity. What hurt us when we get electrocuted is not the electric field, but the current that is generated from the electric field. Now, if you are, for example, so there is a bird here and there is a wire, and usually the electricity need 2 wires, one going and one coming back. So that's the now the bird, usually this one, like in India, the voltage difference between here and here is about 240 volts. Now, at home, you connect, for example, your TV to one wire and the other to the other wire. Then the electric current goes through the complete circuit this way. This is what is useful for me, the electric current. Now, if there is a bird here, I'm not good in drawing, so forgive me. Now the current is gonna, let's see how much current is gonna go through the bird. So there is the current will go from here and then it will reach the bird, but then there is no way the current will go in the return side. So the current is gonna be 0 because there is no, because electricity cannot jump through the air unless these two wires are very close to each other. But normally there is a safe distance between them. So for the bird to be electrocuted, the current has to come back here after it goes through the bird's body. But there is a space between those two wires. Current cannot. Then the voltage will not do me any good. But imagine the bird is stupid enough to have one leg here and one leg here. That bird is gonna be dead. Is gonna be a huge current will go through, and it will die. I think our bodies can get electrocuted if we have about 50 milliamp and above. 1 or 2 milliamp, you will feel a little bit. If it's about from 10 to 20, your body might be able to survive, but you will feel some heat and also your muscles stop moving. The moment the current is 50 milliamp or above, the heart is going to stop. So current is what drive our civilization. If you have, for example, electric fan, what makes the electric fan moves? The current. If the electric car, for example, the current that goes through the electric motors is what makes the motor moves. Current is what we are after. That is the thing that does work and force for us. Yeah, that's a long answer.
Yeah, no, thanks.
Anyone has any other question? All right.
Okay, thank you, Sami. So we will, as I was telling Karthik earlier before others joined in, so we are going to alternate between me and Sami. So today, Sami talked about electrical circuits. So next week, I will talk about, I was thinking something on small on astrophysics, let's say redshift, and then I will let you ask questions. I think you guys have been discussing well. Yeah, go ahead.
So what about trigonometry?
Yeah, I was thinking, oh, maybe trigonometry then next time, next time I'll do trigonometry.
Yeah.
Okay. So I'll do trigonometry next time. Okay. Good. Okay. Good. And then we can, so alternate, me and Sami will alternate between us. Okay, very good. Okay, good. Thank you.
Right. Thanks, everyone. Hope I'll see you not next week, but the week after.
Thank you, sir.
Thank you so much.
Thank you for your valuable time.
And don't hesitate to, oh, by the way, the telescope you're using there
Yeah, we got it.
has been donated by April,
Oh.
who is on the is participating today here.
Oh, really?
Her father gifted her the telescope. Is that right, April?
Yeah, when I was in undergrad, my dad gave me that telescope. So that was over 20 years ago. So
Now she has a bigger telescope, so she passed on the smaller one to us. So yeah, don't hesitate to use it, and tell me if you're facing problems. Okay. Okay, good. Okay, so we will see again next week, correct? Yeah. Thank you for joining us. Yeah. Yeah. Thank you, Ashwati. Bye-bye, April.
see y'all.
Suggest.